Welcome everyone to another session of this cloud data architecture series. So yesterday I published a blog on Medium related to the key considerations while implementing a data lake, and I thought I'll make a YouTube video for this so that I can explain some of the things in a better way. So today we'll go through the same blog. I'll also give you the link of this blog so that you can refer to it in case you would prefer reading instead of hearing to this audio. So let's start. Okay. Um, Many of you would be in the initial phases of implementing a data lake, or some of you might have already implemented a data lake and you must have started using it now. This session would help for those who are just starting their journey for implementing a data lake. And in case you already have implemented, maybe you can just go back and look through some of these key considerations and whether you have considered all this while designing the data lake. So the main audience for this session would be the data architects or the solution architects who are involved in designing any data lake systems. And the primarily I'll talk mainly from the AWS perspective, using AWS services. How should we implement a data lake and what should be the key considerations for this? Right. So data lake is one of the most critical building blocks of any data ecosystem, right? And with the new lakehouse architectures, if you are aware of what is currently happening with the the latest trends, I would say in 2022 is everyone is trying to move to a true lakehouse architecture, where you just have a data lake and you don't have a separate dedicated warehouse. So the data lake itself would act as the primary lake house, and it should be able to suffice all your requirements without having the need of moving the data into a dedicated warehouse. And that brings us to our very first point, that it should be a single source of truth. So whatever data you are getting, right, from, you will be dumping a lot of data from multiple source systems and putting it into your data lake. Now that data should act as a single source of truth. It should not happen that one department brings some of the data and then there's another department who wants some additional data related to that same subject area and they are bringing the data again. So the data lake, right, when you are bringing the data from multiple source system, ensure that you bring the whole data. Let's say you are bringing the customer data and it has 100 attributes in your source, but you just need 60. So don't just bring those 60, bring everything so that it can be used later by other departments. And that would help to make it as a single source of truth. And with the new lakehouse architecture, right, it is going to be the single your data system where you are going to persist the data. You are not going to put it into another warehouse and all. So it becomes important that all the data acts as a single source of truth. So anyone who wants to refer to the data, they just go there and get the data. So it should work as you might have heard the term like acquire once and use it multiple times. So it's based on the same strategy. So bring all the data and in its raw form, right? Don't try to filter out the data, just bring it in its raw form, and then you can have separate layers for creating your curated data or cleansed data, and we'll talk about that in some of the other points, right? So that was the first one. The second is the security and data protection, right? You all are aware of, right? Why security is so important in today's world, and there is a lot of emphasis on building, a secure data lake. So your data lake should be secure. That's a most important criteria for any data lake, right? If you are moving any of your organization data, it should be secure. And it is often said that security is a day zero practice. You cannot really implement security, or it's not an afterthought. You have to start working on the security from day zero. So ensure that you have your data encrypted whenever you are loading the data into a data lake. Let's say you are using AWS S3. S3 is the main service, right, that we will talk about in today's session. You are implementing your data lake using S3. You encrypt all your data. So data at rest, right, it should be encrypted, and then you can use the Inbuilt encryption mechanism that AWS offers. You can have S3 based encryption, right? Or you can also have the KMS encryption. KMS, I would say it is better, so that you have a control over the keys, and you can also provide the access to the users to this KMS, those whom you want the data to read the data, and if you want to restrict access, you can avoid giving them the KMS access. So ensure that whatever encryption mechanism you are using, use it, but ensure the data is secured, it is encrypted. And if you're using AWS, using the internal inbuilt tools, it is just going to help you to do that. Another important is the aspect is the PiPHI data, right? A lot of again emphasis is there for abstracting this data. So whatever abstraction logic you use, you can either encrypt your data, you can either mask your data, you can either tokenize your data. It all depends what strategy you are using. Use any of the strategy which is standard or accepted within your organization or within that particular program, but ensure that you have your data protected, so that your PI data and PHI data, right, the non-eligible user should not get access to that. So whoever needs to have the access to the PI data, only they can get the access. And again, if with AWS, right, there are multiple features that can be used. There is a service called lake formation, wherein you can control the access. And that brings us to the next point as well, right? Governance and sharing. Now, like security, the data governance is also day zero practice when it comes to your data lakes. Ensure that you have proper access control. So speaking about the AWS lake formation service, right, it provides you a fine-grained access control to control your data. So how it would work, right? How would it span out? Once the data is loaded into S3, how are you going to access this? Let's say you are accessing it through Athena, right? So you will create the glue data catalog tables, and you will give access to these tables to have an to query the data in S3. Now, when you are doing this, use lake formation permissions to have a fine-grained access control. When I say fine-grained access control, using lake formation, you can control the access of a particular user or a particular role to any specific table, or even at the column level. So if let's say there is a customer table and it has this PI data as a customer name and customer email, and you have two group of users, say the data engineers and the data analyst, and you don't want the data analyst to have access to your customer name and email, you can do that using lake formation. You can restrict them at a column level. And recently, I think lake formation has announced new features wherein you can also control a particular cell, that is a particular row and a particular column. You can add data filters to that, and you can explore this further. I think it has just been launched a couple of months back, and you can see how it works. At the same time, when you're putting a lot of access control, data sharing is equally important. It should you should ensure that you have the right a mechanism in place to share the data. So if you want to share the data from one account to other, right, there would be multiple AWS accounts in the organization, and you want the other account to use the data from the primary account, you can do that from lake formation. You can have those data sharing kind of a mechanism there, so that again it avoids data redundancy. You don't have to move the data, you don't need to replicate the data. It's just that you share the data from one account to other. Okay. Fourth point is the asset compliance or the handling of updates. Now, this is something new. Those who have built the data lakes, right? I have implemented data lake, 5-6 years back in Hadoop as well. And that time we really struggled with handling the updates, right? With Hive, where you cannot do an update, HDFS, you cannot do an update. You had to write custom code to handle the updates, where you take the backup, then you delete the older data, you add the new inserts, and a lot of things you have to do. but with the modern new age data lakes, right, you are able to do that. So there are multiple open data formats, right, like Apache Hudi or Databricks is Delta Lake, right, that you can use. And now Apache Iceberg is also being, trending a lot. Many new systems have started using it. I think AWS has recently announced its integration, EMR integration with Apache Iceberg. They already had it with Hudi, and now they're also supporting Iceberg. So look at all possible solutions which can help you to implement ACID transactions, to implement the updates. Most important is time travel. Time travel is what that, if you have deleted or updated something, you can still go back in time. You can have those where clauses in your queries and refer to the data what it was before you made some transactions. So have a look at all these things and try to implement this. These are a bit complicated, but it will help a lot. And again, with the latest lake formation features, I think they have a concept called governed tables by which we can get these kind of features as well. So it is worth checking that. I've not used it, but yeah, it might be worth to checking that how lake formation would work in these cases, and whether we can have an ACID compliant data lake in S3 itself using lake formation service. The next is the easy integration with other compute tools, right? Again, this is a very important concept from the lakehouse architecture perspective. What the lakehouse architecture would mean is, you have all the storage at one place, and then you can use any compute of your choice that you want. So the data lake should enable, you to do this. Now that's the main difference, right? See, compare it with any of the warehouses like Redshift or Snowflake for that matter, where you have to load the data within those compute engines, right? You have to load it into Snowflake, you have to load it into Redshift. Now lakehouse architecture says that you can still have the data into your data lake and you can have your own compute engine. So if you have this separate storage and separate compute, you get a lot of flexibility. So ensure you have that, and you have all your data into S3, and then you use the compute engine of your choice. You can have Athena to do the query. If it is heavy, a big data kind of processing, you can use EMR, right? If you want some external tools like Snowflake can read the data from external tables. Redshift Spectrum can do that, right? You can then have your own choice of compute engine. So look for an architecture which you have these two as a separate. Sixth is the most basic of any data lake. It should be scalable, durable, available, right? And the seventh is the backup and replication. Maybe I'll try to talk about both of these together. Scalable, yes, because the amount of data, right, the growth at which it is growing, you cannot predict how much data you would need, how much capacity you would need. So your system should be scalable, and S3 is highly scalable. I mean, you don't really have to worry about capacity planning. Like gone are the days when you had these Hadoop clusters and you have to look for the capacity planning. I remember as an Hadoop admin, we had to provision the data nodes. We had to look at the disk slots on a particular data nodes. Let's say there are 12 slots, then if we have a 4 TB disk, it will give me 12 into 4 as a capacity. You don't really have to worry about that with S3. Same goes with durability and availability, right? It is highly durable. S3 is 11 nines durable. Once the data is stored, even if you want to use it after a decade, it will still be there. You don't have to worry about that. And it should be highly available. It should be available 24/7. You never know which business user would be asked to generate some reports out of it, what insights they want to generate at at any point of time. So it should be all highly available, and S3 supports all these things. It is one of the best services for implement data lakes that support this. Backup and replication is wherein your data lake, you should have a good backup strategy. You should have a way to incrementally back up the things and restore it when it is required. You should be able to replicate it so that even during there are cases like HA or DR, right? You should be able to run your systems with S3 because it is highly available. You don't really have to worry about it. But what you can do is you can also enable a cross-region replication. So what happens is even if a particular region is down, you still have your data replicated across. So yes, I mean all this can be done using S3. Next is cost optimization. Now, again, this is important because when you start, right, you don't really give it a lot of thought because you start with smaller data. But then once the data lake is in place, right, your data will grow in no amount of time. You will immediately start, hitting your upper threshold levels. So ensure you have a proper cost optimizations. And how do you do that? You implement proper lifecycle policies, archival policies, right? S3 has things like intelligent tier. It knows like when a data is being frequently accessed and not, and accordingly it can move across the various storages. Like it has standard storage, it has infrequent access, and there is a glacier for archival. Sorry. So you can use all those things while doing these kind of cost optimizations. Now, the good thing about S3 is, right, all these things come again inbuilt features with S3. You don't have to separately write any scripts to move the data to archive level. So those who come from an, Unix background or HDFS background, right, that time we had to write such scripts in Unix shell scripts to move the data, right? After based on some time interval, we go and check if there are any files which are older than 180 days, then move it. So all these things you don't have to do manually. The best things with S3 is all these lifecycle policies are readily available. It's just a matter of having these implemented. You just need to configure, right? Once these are configured and you put it at the bucket level, then that's it. You don't have to worry about that. S3 will take care of all these movement of data between the storage systems, or archive it, or even if you have put in things like versioning, right, data versioning. So you can have a policy to delete the older versions or archive the older versions. So all these things are readily available. It's just a matter of configuring this. Next is data for everyone. See, data lake, who are the users of data lake? It's everyone. Our data engineers would need it to dump the data. Data analysts would need it to generate some analytical, simple ad hoc interactive queries. Data scientists will need the raw form of data to do some exploration. There would be some business users who want to see some kind of, management information. So data lake should be provisioned for everyone. And then you have when you're building this data lake, right, when you're designing this, you have a layered architecture that I mentioned at the start. You have your bronze layer, silver layer, gold layer, or some of the people would call it as a raw layer or transform layer or curated layer or cleanse layer, right? So you have those layers and you have those that data in those layers and provide the access to that particular user. Okay, example, you bring all the raw data as is in your system in your raw layer, and you have your access to data scientists who want to play around with this data. So they have the most raw data to play around with. It is not summarized, it is not cleansed, it is not aggregated, but that's the kind of data they would like to see to to ask some questions, right? So you can have that kind of implementation. And finally, I think the most important is making your data discoverable, right? Now, most of the data lakes, what happens is you just keep on dumping the data and it is never used. So it is not just an archival system, right? It's not an alternative to your older tapes and all. So you don't want that data lake to be just reside in the system, just holding the data. See, the real value of data is, when it is used, when it is used for querying purpose, when it is used for getting some information or insights out of it. So you need to make it discoverable. How to make it discoverable? You have the right metadata on top of it, right? You have like in Glue data catalog, you have the right tables to access this data. You give the right permissions, you have the right tagging, right, for this data. Now, lake formation also had tag based, approach where you can provide the access, and also you have all these things so that you can see the data, whatever is there, people would be able to make use of it. Now, lineage is something, it is still, there is no service to have a end-to-end lineage, but yeah, you can still have few things like Glue data brew, so that you can profile the data, understand the data, but have all these things in place, right? It's just so what I'm saying, it's not just S3, right? It is the other services also that will help uh, people to access this data, right? So along with S3, just look at the other services which are available within AWS Tag, and that is why I say AWS Tag is one of the best tag to implement a data lakes that are practically usable. It is not just dumping the data, but it is also, you know, about accessing the data and getting the insights out of that. So yeah, these are the 10 key points that I would say. There are few more others also, which, you know, you can think about it, like maybe performance. We have not touched upon that, but again, with performance is more of a compute part. But yeah, you can have the right kind of partitioning mechanism, right? The bucketing policies that you have. So all these things will add to the, you know, having the right prefixes, it can add to the performance. So there are other considerations also along with this, but these are the 10 I think you should start with. And you know, if you're building a new data lake, definitely have a look at all these key considerations, and see if you want to, you know, maybe add few more to it to make your data lakes more robust. But yeah, in the end, I mean, to summarize all these things, right? Do everything that is needed to have a good robust data lake which is scalable and secure. And the most important is build a data lake which can be used by, you know, your different personas within the organization. That is the most important. It should not just become a data swamp where data is just being loaded. It should help the users to generate some meaningful insights out of it. Thank you.